let's start now. So we have here Apple to please lead the prayer. Thank you. We are now 23 in the class. Okay. Okay, thank you so much, Apple. Amen. Amen. So, good morning, class. I'm very happy to see your wonderful and beautiful faces for today. I can see that you're all excited to learn from me today. Yes? Okay, so now let me remind you our virtual class rules. So, just five virtual class rules. You can tap yourselves. So, first, I want you to mute yourselves, but turn on your cameras on. To those who have internet connections, you can just turn on your camera when being asked or it's time for attendance. And also, I hope that you are now on or in a area where it's conducive for you to learn and for you to focus on our lessons. And also, we have here the raise button if you want to be acknowledged, if you have questions or ideas to be shared in the class, as well as we have here appropriate emojis in the chat box. You're always free to write whatever you want to do in the chat box, but please use appropriate, messages and emojis. So now, attendance matters as every day counts. So as you log in here, I hope that you are using our institutional Gmail, so for easy tracking. I can see now that, yes, we are 38 in the meet. So that's great. We are all here today. Tap, tap, tap yourselves for being awesome and being present for today. So that's great. Now it's time for mission accomplished. Please submit your assignments to Einstein as he will be giving me the Google Drive link of the compilations of your assignments. Okay, thank you so much. Being acknowledged now. So now let's review our lesson yesterday. What was it about? Yes, Mariela, it's all about electricity. So the question now is, what are the sources of electricity again? Yes, it can be found in water. And where? Earth's interior, yes. And power plants like fossil fuels and nuclear. Yes, nuclear power plants. Also, it can be found in wind, right? Yes. So now let's just a little bit of shake it up. So now we have here word scramble or arrange me. So it says here a device that increase or decrease voltage of an electric current. So what is it, IQ? What is it? Yes, or Drylin, acknowledged? Transformer, very good. Number 2, any system that is used to generate mechanical or electrical power and can be utilized to power up devices or perform work. What would it be? Power plant. Very good, everyone. Selwyn, very good. Yes, James, very good. Hermanito, very good. Next is shake, shake, shake. I can see that you all learned a lot from our previous discussions. So now let's find out. How does turning out light or turning on the light? Have you ever wondered where all this power came up? How does turning on lights work? Okay? Or by cooking a rice, how does a rice cooker do or powers up to cook your rice? Or right now that we are in a virtual class, we are using mobile phones and desktops to power up our devices to be here in the class. Have you ever wondered how these devices powers up for us to use? Let's find out. So now, welcome to our new lesson for today. It's all about electricity and magnetism, and this is our topic for today is electricity generation, transmission, and distribution. Very good. So now, electricity can be generated into a variety of sources as we have discussed earlier. And now, these sources supplies energy necessary to turn large turbine, which are then connected to a device called generator. Also, it is made possible by interaction between a charging magnetic field. Assembly to a magnetic field will interfere with electrons in the conductor, to induce a flow of electric current inside it. So this is the electrical generators with a wide range of power output. Yes, capacity that are readily available for everyone in the community. So this device, what is it again? Converts what? Mechanical energy into electrical energy. This is the generator. This is the turbine. This is the hydropower plant. And what's inside here is this, the huge turbine generator. Okay, now let's give you an example. Yes, is this familiar? Yes, the Maria Cristina Falls. So we have here hydrothermal energy produce electricity that comes from the energy stored in the surface of water. So Maria Cristina Falls powers up Agos 6 hydroelectric power plant that supplies 70%, yes, 70% of total power of the northern Mindanao. The power plant has 200 megawatts potential capacity supplied by a water flow of 130 cubic meters per second. So imagine how much or how huge or how large it is to produce the whole community, the power up for whole Mindanao actually. Yes, it has 200 megawatts. Very good. So this is now, please take down notes, okay? Now, I am sure you are familiar with the lines that you can see in the streets. Yes, those lines, the black lines you can see. So what would it be? I'm sure it's very familiar to you. It can be seen everywhere. Yes, Mariela and 16 others raised their hands. Now, I can see you're all excited. So the phenomenon was discovered by Michael Faraday, and you can see it, this picture on the right, the magnetic flux or the magnetic foil lines, and it cuts magnetic field which lies between two poles of magnet, and the magnetic field will interfere with electrons in the conductor to induce flow of electric current inside. Very good. So now please take down notes. Yes. And now I have a question here. How does electricity reach us from generating electricity in the power plant? Yes. Now, electricity is all about, yes, all about transmissions or transformers. So electricity flows through large wires connected to step-up transformers. Step-up transformers raise the voltage as high as 765 kilovolts so it can travel long distances. So from 200 megawatts, raise up pagid na niya into 765 kilovolts, traveling to where? Substations. Substations where then we have another transformer which is a step-down transformer which will lower down, step-down transformer between 13 to 2 kilovolts of electricity, and from there, so from the substations, it will travel again to the neighboring yes, poste, kanang nakita niyo sa gawa sa balay, kana sila makastore na sila og 120 to 240 volts. So lower down na siya, going to your electrical box in the house. All great, all great. So let's recap. From power plants to step-up transformer to step-down transformer and to electrical post. Very good. So from 800 megawatts to power plants to step-up transformers, we have 800 kilovolts. Step down to 140 or 13 to, yes, it's still kilovolts. 13 to 2 kilovolts, and then to electrical post from 120 to 140 volts. Very good. Now, I'm asking you, how does your electrical change you? Or like, how does the cost of electricity change you? So you can see in the picture, wow, he's having a hard time to accept the electrical charge. So now, like, are you familiar with ILPI here in Iligan City? So how ILPI charge the use of your electricity? For a month, yes, how much? Oh, the electrical bill for Judy is less than 1,000. That's great. For Zaira, 5,000 a month. That's quite expensive. Anyway, 300. Wow, that's great. So anyway, class, this ILPI charge us for the charge use. So now, I'm just giving you some tricks and tips on how to calculate your electrical cost. So now I can see all of the excitements in the chat box. Thank you so much. I'm very happy that you're all engaged in what we are having today. So now do not worry, as I am teaching you how to do the calculations. So now, are you ready for the maths? Let's do the maths. Okay, electrical total cost. So E, we have here E, the energy used in kilowatt hour. P is power in watts, and then time, which is, it's either seconds or hour. So for now, we will use hour. Okay, so are you ready now? Let's do some sample problems. In this problem, how much electrical energy is used by a 350 watts refrigerator for what? 8 hour. If the cost of electricity here in Iligan is 9.33 kilowatt hour, how much the use of refrigerator cost? Now, first, what's the first step in calculation? Given. Okay, give the given. 350 watts, time is 8 hour. Find the what? Find the E, which is the total energy and the cost of refrigerator. E is P times P, and then cost is cost per kilowatt hour in the city times E. Now, let's do the calculations. Convert the power from watts to kilowatt hour, which is 350 times 1, which is 1 kilowatt hour is equals to 1000 watts. And the answer is 0.35 kilowatt hour. And so for the energy, which is E, now we will use this 0.35 kilowatt hour times 8 hour, kilowatt times 8 hour is equals to 2.8 kilowatt hour, and that is our what? That's our energy. Now let's solve for the cost. So the cost is cost in peso in the city times E. So you have here 9.33 kilowatt hour in Iligan City times 2.8, which is your energy, and that costs us 26.124 pesos. So in 8-hour use of electricity, the charge of that cost is 26.124 hours for the use of refrigerator. Yes, I can see all the excitement. I can see in the cameras. All smiles from James. All smiles from Mariela, Odrylin. Yes, Irish. Thank you so much. To recap, understand the narrative that is trying you to convey the problem. 2, identify the given. 3, convert the values as needed. 4, check your solutions and answers before you submit it. Now, these are the things. Playing it all to you. Jot it down. So now, let's recap. Our key concept for today is that power plant is what? A facility where electricity is generated from energy sources. Number 2, generator is a device that converts what? Mechanical to electrical energy to do what? Work. Very good, Mariela. Next is transmission lines are power cables that carries high voltage of electricity over long distances. Number 4, distribution lines carries electricity at lower voltage that is used to distribute power plant to our neighboring hood. Now, as you can see here, natin mga poste, and that is the use of distribution. Now, thank you so much. And if you have problems here over the lessons that we have today, please jot it down and raise the question tomorrow before we start our new lesson. Okay, thank you so much. And I hope you have a lot of learnings today. Thank you so much. All smiles from all together. Yes, raising up. Very good from Einstein. Very good. Thank you so much and all the engagement. I really love that you're all smiles and you're all excited. Yes, if you have questions, please jot it down. And tomorrow, we'll see you again tomorrow at 7:30 still. So, thank you so much for coming here. We are now 35 in the class. So, thank you so much, students, and see you all tomorrow. Bye!